Welcome, class, to the Intro to Java Programming. In this lesson, we will review scope as it relates to local variables. Visual and code examples will be provided to illustrate how it works, along with some rules and guidelines to follow. Scope is a concept that refers to the accessibility and lifetime of a variable. Each code block can declare variables. Understanding scope will help know which code blocks can access which variables. Also, when certain code blocks have executed, their variables no longer exist in memory for other code blocks to access. This lesson on scope applies to the variables of a method and not accessibility for the class, constructor, methods, or properties. Please see Lesson 2 on the class, Lesson 3 on methods, and Lesson 4 on properties. What is the difference between a property and a variable? This can be a difficult answer depending on the programming language and the opinion of other developers, but here's a general answer. There are 4 types of properties and 2 types of local variables. Properties are declared inside a class but outside of all methods. Class variables will use the keyword static and should be marked final. Properties are private and will have a getter and/or setter methods. Instance variables are private, no getter and setter methods, and can be used by methods of the class. Fields are public with no getter and setter methods and are used to define a data object. Local variables are defined inside methods, constructors, or code blocks, and the value can be changed. Constants are typically a class variable, instance variable, or local variable with a value that cannot be changed and marked with the keyword final. Based on the definitions provided, most developers use the terms class variable, property, instance variable, and field interchangeably as they are declared inside the class. For the rest of this lesson, I will loosely use the term property unless otherwise specified. Also, for the rest of this lesson, the term variable will be used to represent a local variable or constant inside a method or code block. Here's a good visual example of scope. Let's say this box represents a class. Inside the class are properties, constructors, and methods. Inside each method can be variables and code. Scope refers to the accessibility of variables. For example, variable 1 in method 1 is accessible by the code of the method. Variable 1 is not accessible by the code of method 2, and variable 2 inside method 2 is not accessible by the code in method 1. Accessible means the variable is available for read and write access. Constants are available for read access. Knowing which variables can be accessed can be a little confusing at first, but let's go over a few more examples. Let's add another method called method 3. This method will have one local variable and code. Inside the method is a for loop and code block. The for loop contains a local variable, and inside the code block is a variable and code. To get a better understanding of scope, consider the code block for method 3. The code block for the class is the parent code block. Method 1 and method 2 code blocks are siblings to method 3 code block, and the for loop inside method 3 is a child code block. A simple rule to follow is this. A code block can access its own variables along with its parents, but cannot access any sibling or child code block variables. This means the code in method 3 can access variable 3 and the class property, but cannot access variable 4 or the loop counter variable I because it is found inside a child code block. It also means method 3 cannot access variable 1 or variable 2 because they are found inside sibling code blocks. Let's add another child code block inside the for loop. Here is an if statement with a true condition code block and a false condition code block. Each code block contains a local variable. This true condition code block can access variable 5 because it's a member of that code block. It can also access variable 4 and variable 3 because they are parent or grandparent code blocks. The property of the class is also accessible. Time for a Coach Joe challenge question. Can the true condition code block access variable 6? It is true the else code block is a member of the for loop code block. However, it is a sibling code block of the true condition and therefore not accessible. Creating variables that are accessible to a large scope of the project could be dangerous and should be avoided. Here are a few rules and guidelines to consider. Never create a globally public variable. Bad things can happen when too many classes, methods, or developers can change a variable from anywhere. Imagine we have code to control the inner workings of a television. One developer uses a global variable to hold the volume level. Another developer uses that same global variable to hold the channel. By changing the volume, the channel is also changed. Not good. This leads us to the next guideline. Avoid creating variables that can change. This is the ideal situation you should strive for in your code. Few, if any, variables. If a variable is needed, create it in the most localized scope possible. Define the local variable in the scope where it is needed. Limit child code blocks requiring access to the variable. And if a grandchild code block requires access to the variable, consider designing a better approach for the process. Create constants or final variables whenever possible. Only make it a variable when needed. Constants cannot be changed. There is no risk other methods or developers will change this value, and supports the rule to avoid creating variables that can change. With methods, it is better to pass in the value needed than create a local variable. This supports the rule about only creating variables when needed and encourages the topics of functional programming and dependency injection. Let's look at some code next. Open the first program project in IntelliJ, close any open class tabs. Let's create a new package called Scope. Let's create a new class called Scope Example. This class will be used to show many scope examples with local variables. This is a class property. This is the first of 3 methods. This is a local variable for the method. This is the second method, and this is a local variable for the method. This is the third method, and this is the local variable for the method. Inside this method is a for loop. This is a local variable for the for loop code block. Inside the for loop is an if statement. This is a local variable for the true condition code block. And this is the else code block, including a local variable. Time for a Coach Joe challenge question. Which variables are in scope for method 1? The choices are property 1, variables 1 through 6, and the for loop counter I. Correct. Property 1 is available to all code blocks of the class, and variable 1 is a local variable created by the method. Here is a summary of variable scope for method 1. These variables are in scope and available, and these variables are out of scope and not available. If the comment block is turned off, notice the compiler errors for the variables out of scope. Cannot resolve symbol. These variables might exist, but they're out of scope for this code block. I'll turn the comment back on. Take a minute to identify variables that are in scope and out of scope for method 2, 3, the for loop, and the if blocks. Pause the video and make a comment with your answer. Here's the answer for method 2. Here's the answer for method 3, the for loop, the if statement true condition, and the if statement false condition. Here's a summary of all the code we wrote for this lesson. You should now have an understanding of scope for local variables inside a class. The code block can access its own variables along with its parents, but cannot access any sibling or child code blocks. Some rules and guidelines were provided for creating variables and constants along with visual and code examples. In the next lesson, we'll discuss user input with the scanner class. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!